Every time you order a package from Amazon, a hidden carbon footprint is created. But have you ever wondered how Amazon actually calculates those emissions? How does the company estimate the carbon impact of millions of deliveries, thousands of warehouses, hundreds of data centers, and a global supply chain that stretches across the world? Today, we are breaking down exactly how Amazon calculates its carbon emissions, the methodology behind the numbers, and why measuring emissions is far more complicated than most people think.
Amazon is one of the largest companies on earth. Its operations include e-commerce, logistics, transportation, cloud computing through AWS, physical stores, data centers, and manufacturing partnerships across the globe. To track climate impact, Amazon follows the Greenhouse Gas Protocol, which is considered the global standard for corporate carbon accounting. Under this framework, emissions are divided into three categories: Scope 1 emissions, Scope 2 emissions, and Scope 3 emissions. Understanding these three categories is the key to understanding Amazon's carbon calculations.
Let's start with Scope 1. These are direct emissions from sources that Amazon owns or controls. Examples include fuel burned by Amazon delivery vans, trucks and transportation equipment, backup generators at facilities, natural gas used in buildings, refrigerants leaking from cooling systems. To calculate these emissions, Amazon tracks fuel consumption and operational data. The basic formula looks like this: carbon emissions equals activity data multiplied by emission factor. For example, if a delivery van burns 1,000 liters of diesel fuel, Amazon multiplies that fuel consumption by a scientifically established emission factor for diesel. The result is the amount of carbon dioxide equivalent, or CO2e, emitted into the atmosphere. CO2e is important because it combines multiple greenhouse gases into a single metric. Methane and nitrous oxide are converted into their carbon dioxide equivalent based on their warming impact.
Next comes Scope 2. These are indirect emissions from purchased electricity. Think about Amazon warehouses, fulfillment centers, offices, and AWS data centers. Even if Amazon doesn't burn fuel directly, electricity generation can still produce emissions. To calculate Scope 2 emissions, Amazon measures electricity consumption in megawatt hours and multiplies it by the carbon intensity of the local power grid. If electricity comes from a coal-heavy grid, emissions are higher. If electricity comes from renewable sources like wind or solar, emissions are lower. Amazon reports both location-based emissions, which reflect the average emissions of the local electricity grid, and market-based emissions, which account for renewable energy contracts, power purchase agreements, and renewable energy certificates. AWS follows the same methodology when calculating cloud-related emissions. Amazon first estimates energy consumption and then applies regional emission factors before accounting for renewable energy purchases.
Now we reach the biggest category, Scope 3. For Amazon, Scope 3 represents the majority of total emissions. These include emissions that occur outside Amazon's direct operations. Examples include manufacturing products sold on Amazon, supplier operations, construction materials, transportation by third-party carriers, employee commuting, business travel, end-of-life disposal of products. Calculating Scope 3 emissions is much harder because Amazon doesn't directly control these activities. Instead, the company collects supplier data, purchasing records, transportation information, and industry averages. For example, if Amazon purchases a large quantity of steel, it can estimate emissions using life cycle emission factors for steel production. If a third-party logistics company ships products, Amazon estimates emissions using shipment distance, transportation mode, fuel type, and standardized emission factors. This process combines real operational data with scientific emissions databases. At its core, Amazon's carbon accounting follows a simple principle: measure activity, apply an emissions factor, convert everything into CO2 equivalent, then aggregate the results across the company. Imagine calculating emissions from hundreds of aircraft, tens of thousands of delivery vehicles, thousands of buildings, hundreds of renewable energy projects, millions of products, global supplier networks. The challenge isn't the formula. The challenge is collecting accurate data at enormous scale.
So what do the numbers look like? According to Amazon's sustainability reporting, the company reported total emissions of approximately 68.8 million metric tons of CO2 equivalent in 2023. That's down roughly 3% from the previous year. Amazon says improvements were driven by renewable energy expansion, efficiency gains, and lower carbon intensity across operations. At the same time, some direct operational emissions increased because Amazon continued expanding deliveries and business activity. This highlights a major challenge in sustainability. A company can become more efficient while still generating enormous absolute emissions because of growth.
Measuring emissions is only the first step. Reducing them is the harder challenge. Amazon says its strategy includes expanding renewable energy projects, electrifying delivery vehicles, improving logistics efficiency, designing more efficient data centers, reducing packaging materials, working with suppliers to lower emissions. The company reports that it matched 100% of its electricity consumption with renewable energy in 2023 and maintained that level in 2024. Amazon has also deployed more than 30,000 electric delivery vehicles globally and continues investing in low-carbon transportation technologies. The company is targeting net zero carbon emissions across its operations by 2040 through its Climate Pledge initiative.
So how does Amazon calculate carbon emissions? The answer is surprisingly straightforward. Track activity data, apply scientifically established emission factors, convert everything into CO2 equivalent, then combine emissions from direct operations, electricity use, and the entire supply chain. The calculations may sound simple, but measuring emissions across one of the world's largest companies requires billions of data points and constant updates. As climate reporting becomes increasingly important, carbon accounting is becoming just as critical to businesses as financial accounting. And whether Amazon ultimately reaches its climate goals or not, understanding how these emissions are measured is the first step towards understanding the true environmental impact of modern commerce. If you found this breakdown useful, subscribe for more deep dives into sustainability, technology, and the business systems shaping our future. Thanks for watching.